Okay, as we know, for a system, it can have heat transfer, work transfer, and mass transfer with its surroundings. Because of those interactions, the thermodynamic properties of the system may change. So what is a thermodynamic property? A thermodynamic property is a characteristic of a system to which we can assign an unambiguous value at any given moment without knowing the history of the system before that moment. So here in this definition, you should pay attention to these two phrases. Okay, the first one is unambiguous, which means such a value should be unique. Should be the same for different people. And the second phrase is without knowing the history. So the property, in fact, only depends on the condition of the system at the moment when we try to find out this property. It should not depend on the history before that moment. Okay, what happened before that moment. Okay, it only depends on that moment itself, not the other moments. Okay, let's see a few examples of thermodynamic properties and quantities which are not thermodynamic properties. Okay, first, is the velocity of a system its thermodynamic property? Okay, the answer is no. The reason is because the velocity of an object, in fact, depends on reference frame. For example, when we look at an airplane flying overhead, we may do a measurement and say its speed is like 500 miles per hour probably. However, that is based on our reference frame, right? The reference frame fixed to the ground. So in such a reference frame, the speed of the airplane is 500 miles per hour. But if we change a reference frame, for example, if I use a reference frame fixed to the airplane, say from the perspective of a passenger inside the airplane, he or she may feel that the airplane in fact does not move at all, right? Its speed is 0. So you can say that the velocity or speed of a system or an object in fact is not a thermodynamic property, although in many situations we can give a very meaningful value to velocity of an object, but that does not make it a property. The reason is because different people may give different values to velocity. Okay, the second question. Is the elevation of an object a thermodynamic property? Okay, just take your time and think about this question. You can pause the video and think about it. Okay, the answer again is no, for the same reason as velocity, right? Because elevation again depends on the reference frame we choose. It depends on the reference, reference ground level we choose. Because elevation is always, defined relative to a reference 0 elevation level, right? The ground level. So when you choose different reference level, then the same object may have different elevation values. The third question, is the volume of an object a thermodynamic property? Okay, now this time the answer is yes, right? Because no matter which reference frame we use, the volume of an object is always the same. So, that means this quantity, okay, volume, in fact, has an unambiguous, unique value at any given time moment. Okay, that doesn't mean the object always has the same volume all the time. Okay, it doesn't mean that. An object can change its volume. For example, if you have a balloon and it is being inflated, obviously its volume is changing all the time. But the point here is that at any moment, at any specific moment, it has a specific volume, right? It has a certain number a certain volume value, which is unique, which is unambiguous, in the sense that anyone has a proper volume measurement equipment can do the measurement and find out how much the volume is, right? So there's no any ambiguity here. It's totally unique. It is also, only dependent on the current condition of the object at the given time moment. It has nothing to do with what happened to this object before that moment, right? At any given moment, there is this, fixed volume value for this object. So it is a thermodynamic property. For the same reason, you can find that the pressure of an object, again, is a thermodynamic property. Okay, here, when we use pressure, this word pressure in thermodynamics, we always mean absolute pressure. Okay, it's not gauge pressure, it's absolute pressure. So the absolute pressure value is always unambiguous. It does not depend on any reference frame, anything like that. Also, it only depends on the current condition of the object or the system. It has nothing to do with what happened before the current moment. Another question. Suppose you step into a kitchen and you see such a saucepan of water which is boiling on the stove top. Is the amount of heat added into this pot of water in the last 1 minute before you came into the kitchen a thermodynamic property? Okay, how do you think? Is this a property? Can you give this quantity, that is the amount of heat added to the water in 1 minute, an unambiguous value? Well, yes, you can, right? As long as you know how much heat has been added into the water in 1 minute. But does this make this quantity a thermodynamic property? Well, the answer is no. It is in fact not a thermodynamic property. Because to be a thermodynamic property, in fact, the quantity has to be only dependent on the condition of the system right now, okay? At this moment, okay? What kind of condition it has. Okay, that determines all those properties of the system. But you can see that when you step into that kitchen and seeing this water boiling, you probably can find out, how high the temperature is, what the pressure is, things like that. or how much mass this water has, how much volume it has, but definitely by no means can you find out how much heat has been added into this water in the past 1 minute, right? That totally depends on the detailed history of this heating process in the past 1 minute, right? You can have a high heat in the first 30 seconds, then very low heat in the last 30 seconds, or you can have a very uniform, heating in all this 1 minute. You can even have, a different amount of heat input that can all bring the water to such a boiling condition, right? So it's obvious that the amount of heat added into the water in the past 1 minute is not a thermodynamic property. It does not only depend on the current condition of the water. Instead, it depends on the whole history, what happened in this whole 1 minute. Okay, the next question is the amount of thermal energy stored in the water a thermodynamic property? Now this time the answer is yes. Although probably we still do not quite understand what this term thermal energy mean in this course, but somehow our intuition tells us that the amount of thermal energy stored in water is a thermodynamic property, because it should be a quantity that only depends on the current condition or the current state of the water. It has nothing to do with what happened before the current moment. Also, it has nothing to do with the reference frame we take, right? So say there is like 100 joules of energy stored in this water at this moment because its temperature is so high and its mass is so and so. So basically this is a thermodynamic property, okay? Because first, it is unique value, okay? Anyone with enough knowledge or has proper measurement device can find out this value, and the value should be the same for different people. And secondly, this value does not depend on the history of the system, right? Okay, it does not depend on what happened before the current moment. So here are some examples of thermodynamic properties. Okay, mass, pressure, temperature, volume, density, they are all thermodynamic properties. And in this course, we will also introduce properties like internal energy. Okay, we use capital U for that property. Enthalpy, capital H. Entropy, capital S. And specific internal energy, the small u, specific enthalpy, small h, specific entropy, small s, specific volume, lowercase b, and quality x. Okay, you will understand what these properties mean when we get into the later chapters. Out of all these properties, 3 stand out as so-called fundamental properties. Okay, these 3 are pressure, temperature, and volume. The reason why these 3 are considered as fundamental is because these 3 can be measured directly. Okay, you can use a pressure gauge to measure pressure. You can use a thermometer to measure temperature, and it's also very straightforward, typically straightforward, to measure volume, right? You can use a ruler, things like that, to find volume. Okay, so in our next video, we will discuss these 3 fundamental properties. Thank you for watching this video. See you later.